Okay, so first of all, to implement the system call, we need to manipulate our process table. The process table is actually located in the improc.h header file, and all we need to do is add in this one extra field, an integer called access level, and we'll be manipulating this integer throughout our project. Okay, now to actually create the system call function, we need to first define an entry within the system call array, which is located at table.c. As you can see here, we have one entry at index 0 for the get access level function, and another entry at index 35 for the set access level function. Cool. Since the user probably won't memorize the numbers, we actually need to define it to a keyword. Easy to remember. So if you go to include Minix, and there's a call number header file, and in there we're defining this keyword get access level and set to the value of the system call number, which is 0 for get access level, and another one for set access level, and it's defined to be equal to 35. Great, so after that's defined, we can go back to our process manager folder located in user source, servers, process manager, and as you can if we go to, we can actually define the prototype in the proto.h header file. So here's the header file, and as you can see here, we have the functions already defined for get access level and set access level. Now we also need to implement them in C file. So here is the set access level.c file, and this is where we implement the functions. As you can see, I'm including the input, the process table, and pm.h to send messages or to receive messages from the callee method call. Okay. Now, and lastly, after implementing it, we also need to include it in the make file, and that is, and after, so you can see it's both the functions are right here. Okay, and that's pretty much all the changes you need to make within this file to create a system call. So that's great. But to create a library call, you need to edit different files, right? So let's um, include the prototype for the system call function in a header file. As long as it's in user.include, it's fine. So in this case, we have it actually in the uni std header file. So as we scroll to the bottom, we can see here, or if you do Control F, let's do Control F. Why not? Let's do get access. Here it is. So as you can see here, we define our system library calls. Here that requires a PID, and this requires a PID and a level to set it to. Now, after defining the prototype, of course, we need to implement it somewhere. We're going to implement it in the user source library C, system Minix. Bam, we'll implement it in this folder right here. So you can see my get access level C file right here. It's basically just getting the PID from the user, putting in a message, and returning the system call. So that way the user doesn't have to worry about any like lower level system calls and whatnot. So after you implement the functions, you also need to include it in the make file of this folder. So this make file is right here. As you can see here, we have our get access level, our set access level, and you also have our harness.c, which is for testing. And to implement that, we do the same thing, except that I created a different header file called harness.h within that user source include file. So that is pretty much all the changes we need to make to implement the system call and the system library call. To make the man pages appear, all we need to do is go to user source. We go to man. Oh, maybe I wasn't man. Yeah, user source. There it is, man. I think I put mine in man 1. So here it is. I have my get access level man file right there. And of course, I need to include it in the make file of this page. So in this make file, you can see that I have my get access level header file and my set access level header file. And that is pretty much all the changes I need to make to Minix in order to implement this project. Thank you very much.